Okay, it's my dog and I helping you solve this problem. Okay, so let's look at this. F1 is 3 meters from the left side, so this is at 3 meters. And F1 we'll say is 0, is at 0 from the left side. Okay, the person is 0.5 meters, so it's 8.2 meters long. If they're half a meter from the right side, does that make them 7.7 meters? Right, so there's going to be a force down. So we've got 63 times 9.8, right? So when I say G, I mean 9.81, not grams, but 9.81 newtons per kilogram, right? So 63 G acting down at, I believe that's 7.7 meters, right? And I got that by saying 8.2 minus 0.5, right? The beam's own gravity is at 4.1 meters, so let's draw a picture of that. So 18G, and that's going to be at 4.1 meters. Right, so now we've got this force, force 2 is acting upward. I'm going to just guess that these are both upward. Even though I know, by the way, that, right, that F1 is actually probably going to be downward, right? We'll just say that they're upward. Okay, so here we got 4 forces here. We got F1 acting up at the left side. We've got F2 acting up at 3 meters from the left side. We've got the force of gravity of the beam acting at the center, okay? Okay, and then we've got the person half a meter from the right side, so 8.2 minus 0.5, I really think is 7.7. But I'm a little dodgy about that, that kind of math like that. Okay, so there is nothing going on in the x direction. Now I can set up, because all of these are either straight up or straight down. There's no x. But we can now set up our y equilibrium, right? So y equilibrium is F1 plus F2. And what I tend to do, I'm such a spaz, I just start on the left side and just move my way to the right. Okay, minus 18G, minus 63G is 0, right? And now let's set up our torque. Let's do about the left side. Okay, about the left side, we've got 0 times F1. And then let's see, that would be, this would be an anti-clockwise torque because it would tend to rotate it that way, right? So minus 3 times F2. Again, I'm just doing torque as just RF, right? Okay, let's see, plus 4.1. This is the gravity of the beam, right? Times 18G. Plus the person, so plus 7.7 times 63G. And then that's equal to 0. We got 1, 2, 3, 4 forces, right? And then notice that this is solvable for F1, right? So let's just solve that for F1. I think what I'm going to do is I'm not even going to use my solver, but okay, so 4.1 times 18 times 9.81 plus 7.7 times 63 times 9. Get that answer, and then I think if I just divide that by 4 or divide that by 3, that will give me 1827.6. Yeah, there we go. Okay, so F2 all right, so I've got one of the answers, and now I'm going to pick off the other one, right? So I'm going to substitute in for this, right? So if I substitute in, I go F1 plus 1827 minus 18G minus 63G equals 0. Remember, these G's are 9.81. Okay, that's what I'm doing here. All right, so here we go. So all I have to do is I guess to do this, I just go 18 times 9.81 plus 63 times 9.81 minus that guy. Ooh, and I get negative. I get F1 is negative 1032.993. Okay, so I would say 1032.993 newtons down. And then this is up because it's positive, right? Because it came out positive, it's up. Because this guy came out negative, it's down, right? All right.